Hello guys, welcome to lesson 2, acquire 2 of our first packet of the new year. This is unit 5 cycle 1, acquire 2. We are going to be applying key features of quadratic functions. So everything we learned last time we're going to be using again today. So our learning target is going to be very similar. It is going to be, I can identify key features of quadratic functions. And those include the vertex, the min and max values, zeros, X and Y-intercept. This time we are going to add domain and range. It might have been in your learning target last time, but we didn't do it in the first acquire. But today we are going to be looking at domain and range. And then lastly, the axis of symmetry. I abbreviate with AOS, but that stands for axis of symmetry. So starting with example 1, today we're going to be working with word problems and then identifying all of these key features using the word problem. You will be using your calculator. So you entered your pet frog in a jumping contest. He won first place for both the longest distance traveled in one jump as well as the height of his jump from the ground. The path of his jump can be modeled by the quadratic equation h of x equals negative 1 over 4x squared plus 4x, where h is the height from the ground in feet after x seconds. So before anything else, I'm going to go ahead and label my x and y axis. So they tell me x seconds. Well, this is my x axis. So this is going to be seconds. The other variable they give me is height, and it's in feet. So if this is seconds, this has to be feet. So I label my x and y axis. Now, remember that we know this is a quadratic function or a parabola because it has this x squared. So that's how we know it's going to be a parabola, that U shape that we learned of in acquire 1. So we're just going to follow these steps. It says graph the quadratic function in your calculator. So you should have your calculator. Turn it on. You can either go to a new document or you can go down to the actual picture of a parabola, now that you know what it's called. And we're going to graph this. Now, mine still has stuff from last time. Here's a new graph. We are going to type only what comes after the equal sign. So h of x is the same thing as f of x, which we already have. So I'm just going to type in this into my calculator. Negative 1 over 4x squared plus 4. So negative control divide 1 over 4 x squared plus 4x. And I'm going to graph it. Now, it looks like just a straight line, right? But we know that it has to be a parabola because we have x squared. So I'm going to zoom out to see if that makes it look any different. So menu, window zoom, zoom out. Click it a couple times and there we go. There's our parabola. So it says determine points by opening a table. So we know it's a parabola. Now I want to find the points from the calculator to be able to graph it onto my paper. So to get a graph, we hit Control and the letter T for table. And it's going to give us a split screen, and it's going to give us a table. Now, if we look at the graph, we don't need every number that's on the calculator. If we look at our graph, we are only looking at quadrant 1. So that means our x values are positive and our y values are positive. But the first point that we want to look at is 0, 0. So I'm going to scroll up to 0, 0, or to where my x value is 0. Y is not always going to be 0, but in this case it is. And I am going to use my calculator to copy down points to create my table. I'm going to do it horizontally because we have more space. So 0, 0. And then I go to the next point. My next point is 1 and 3.75. We don't use that number. Why? If you said because it's a decimal, then you are correct. So we're not going to use those decimal numbers. We only want whole numbers. So the next point that I'm going to use is 2, 7. And then I go down and I do 4, 12. So it's like every other one we're going to use. So far, all of our x values have been even numbers. And 8 is an even number. So we just scroll 10, 15. Our graph goes to 20 on the x and y axis. So anything bigger than 20 we're not going to use because we won't be able to graph it. Let me scoot this over. 12 and 12. 14 and 7. 16 and 0. And if I keep going, it gives me negative numbers, which I can't use because we're looking only at positive numbers. So that's it. That is my table. Now it says, use the points to graph the quadratic function on your paper. So now I just take these points and I put them on my graph. So 0, 0, 2, 7, 4, 12, 6, 15, 10 and 8, 16, 10, 15, 10, 11, 12, 12, 10, 11, 12. So you can see the parabola start to take shape. 14 and 5, 6, 7, and then 16 and 0. So we can see that it is a negative parabola because it looks like a frowny face. I'm going to connect these points. Remember, when you connect these points, try to make it look as curvy as possible. Sometimes I turn my paper upside down because that makes it easier, or sideways, for me to make it look more like a U instead of a V. Now, it's not perfect, but you get the picture. So now we're at D. Is this situation discrete or continuous? Should we connect these points with a line? Well, Miss Flores got a little ahead. Yes, it is continuous. We connect those points because the frog doesn't stop moving again until it touches the ground when it lands. So this is where the frog starts. It jumps, it reaches that highest point, and then it lands back. It doesn't stop and suspend in the middle of the air. So I got a little ahead of myself, but this is continuous. And we do connect the points because the frog doesn't stop moving again until it touches the ground when it lands. So now we get to all of those key features that we learned about in Acquire 1. So E says, is there a maximum or a minimum? And what is its value? So remember, the maximum and minimum are always where the vertex is, and the vertex is the middle point. Well, this is my maximum. And it is the maximum because it is the highest point. So there is a maximum. And remember, when we list the max value, we only want the y value of the ordered pair. So this ordered pair is, this is 5, 6, 7, 8, 16. So I'm going to write it. But the maximum is only the y value. So I'm going to write 16. And the y value is feet because the y-axis is feet. So the maximum is 16 feet. What does the maximum, let's underline maximum. What does the maximum represent in the situation? It represents the fact that the frog reached 16 feet after 8 seconds. It is also the highest height that the frog reached. So it didn't go past 16 feet. G says, is there any symmetry to the quadratic function? And what is the line of the axis of symmetry? Well, yes, there's symmetry. because we have a middle point, and if I cut my parabola down the middle, right here, that's going to give me two equal sides, pretending that my parabola is actually exactly the same on both sides. So yes, there is symmetry. And the axis of symmetry, or AOS, the equation is x equals, the maximum is that point, it went through that point, so it's 8, because it's the x value. Remember, it's like the vertex. So the maximum value here happens to also be the vertex, so I want the x value of that vertex. This is my vertex, or my axis of symmetry goes through that point. Now we get to the X-intercept. What is the X-intercept, and what does the X-intercept represent in this situation? Well, in this particular example, we happen to have two X-intercepts, right? X-intercepts are also roots, solutions, and zeros. So I have one X-intercept here, and I have one X-intercept here. So I'm going to write both of those as ordered pairs. So I have 0, 0, and 16, 0. Remember, when you have an X-intercept, it is also, or always, a number, and then a 0 is in the Y place. It is always a number on the X side, and then a 0 on the Y side. This X number is 0. This X number is 16. So both of these have a 0 for the Y place. So what do these 2 points represent in this frog's jump? Well, here the frog is on the ground, and here the frog is also on the ground. So it represents the 2 times the frog is on the ground at 0 seconds and 16 seconds. So I included the time because the X-intercept deals with my x-axis, and on the x-axis it deals with seconds. So it's the 2 times that the frog is on the ground at 0 seconds and 16 seconds. So now we move to I. What is the Y-intercept? Well, if I look at my y-axis deals with feet. So this answer is going to have to do with the height in feet. So what does the Y-intercept, and what does it represent? So this point right here, that is my X-intercept, also happens to be my Y-intercept. So this point is the X-intercept and the Y-intercept. And that ordered pair is 0, 0. Well, if we're talking about feet, what does it represent? It represents the frog being on the ground. That's where it starts. It's the starting place of the frog at 0 feet, or on the ground. All right, almost done. J, what is the reasonable domain for this situation? And are there any values that would be unreasonable to include? So domain, you hopefully remember, is x, right? So domain is the x value, and range is the y value. So on my x-axis, it's talking about seconds. So what is the reasonable time for this situation? Are there any values that would be unreasonable to include? So if I'm talking about domain, we're going to have it like this, right? Remember, the smallest number goes on the left, the biggest number goes on the right. So if I look at my x values in my table, what is the smallest x value I have? 0. And what is the largest x value that I have? 16. So that's what I'm going to use down here. My smallest x value is 0. My largest x value is 16. Can it equal 0? Yes, because at 0 seconds up here, the frog is on the ground. Can it equal 16 seconds? Yes, because at 16 seconds, the frog is somewhere. It is on the ground. Now, unreasonable means doesn't make sense. So are there any values that don't make sense to include in this domain and range? And there are. Unreasonable values would be any negative numbers, because we can't have negative seconds, right? We can't have negative time. And anything that is greater than 16. Because after 16 seconds, the frog's on the ground. It doesn't keep going down below the ground. It just stops. So our time spans from 0 seconds to 16 seconds. And after 16 seconds, the jump is over, so it doesn't really matter. So for range, we're going to do the same thing, except we're going to be looking at the y values. So we're going to have our inequalities less than y less than. I want my smallest y value and my biggest y value. So I'm going to go back to my table. My smallest y value is 0. And my biggest y value is 16. Don't go to the end, because the y values change, right? They increase, they hit that vertex or maximum value, and then they decrease. So for both of these, it just happens to be 0 and 16. They're not always going to be the same. So 0, 16, it equals 0 because that is the height. It does reach 0 feet, and it does reach 16 feet. Underline the wrong thing. Unreasonable is the same as the domain. So unreasonable is the same as the domain. So any negative numbers we're not going to use because the frog can't go underground. It doesn't hit anything below 0 feet. And the maximum value it reaches is 16, so it can't go any higher. All right, so moving on to the next example, another word problem. All right, so this time we're talking about an acorn, and it drops from a tree branch 20 feet above the ground. They give us the function that gives us the height of the acorn in feet after t seconds. Well, seconds is a form of time, and time is independent, and the x is the independent, so this is going to be seconds, and our height is in feet again, so this is going to be feet. So we're going to label our x and y axis. So we're going to do pretty much the same thing as we did last time, except our function is different this time. Now, notice that here they have negative 5 over 4 t squared. Well, in the calculator, we cannot type t squared. So over t squared, I'm going to write x squared, so that when I type it in the calculator, I'm not tempted to use that t. So I'm going to open a new page. I'm going to add a graph. And I'm going to start typing after the equal sign. So I'm going to type in negative 5 over 4 x squared plus 20. Okay, we can see two sides. We don't see the maximum. I know it's a maximum because it gets wider this way and it gets wider towards the bottom, or whatever side it's moving towards. So I'm going to zoom out a little bit. I don't really need to, but if you want to make sure that it's a parabola, zoom out. There's my vertex. Well, I need the table, so Control T. I'm going to go to 0 because that's my first x value on my graph. So I'm going to create my table from the calculator, just like last time. So 0, 20. Remember, we skip all of the decimals. We only want whole numbers because it's really hard to graph decimals. And then 4, 0. And this one is super short because after 4, 0, we get to those negative numbers, and we don't deal with negative numbers when we have word problems. We're only looking at the first quadrant because usually x is going to be some form of time, and we can't have negative time. So usually we're only going to be working with the first quadrant. So this time I only have 3 points to actually graph. So I'm going to graph those. 0, 20. I have 2, 15. And I have 4, 0. Now, here the parabola looks a little different, right? It got a little squished because of the table. We know that there's another half to the parabola, but we're only seeing half of it because we're only looking at that top square of the graph. Now, this one doesn't show the whole parabola because it tells me here the acorn drops from a tree branch 20 feet above the ground. So it's starting 20 feet above the ground. It's not starting on the ground, moving up and then falling. It's starting 20 feet above the ground, and all that's happening is it falls. I got a little ahead again. Is it discrete or continuous? I went ahead and connected it. It is continuous, because the acorn, again, similar to the frog, the acorn does not stop moving until it hits the ground. Right? It doesn't just stop midair and float there. Once it falls, it doesn't stop until it hits the ground. So is there a maximum or a minimum? Well, on our graph, in our calculator, we saw that there was a maximum. So my maximum is this point right here. Remember, we're only seeing half of it on our paper. But in our calculator, we know that it is a full parabola, and that is a maximum. So it has a maximum. That ordered pair is this first point, so that's my maximum. It is 0, 20. What is the value? 20 feet. What does the maximum represent in this situation? It represents the starting or highest point the acorn reaches. So that y-intercept is our starting point. All right, is there any symmetry to the quadratic function? What is the line of the axis of symmetry? Yes, there is symmetry. Right, I have a full parabola. I am only seeing on my paper that one little section. So even though I don't see the full parabola on my paper, there is a full parabola. It would be over this way. So the axis of symmetry always goes through the vertex. The vertex is always your maximum or minimum. Since this is my maximum, that means my axis of symmetry goes through that maximum point. So my axis of symmetry is this imaginary line that would go through that maximum. Okay. It's kind of hard to see because it is also the y-axis. Well, the axis of symmetry, so is there symmetry? Yes, there is symmetry. And the axis of symmetry is going to be x equals my x value of the maximum is 0. So the equation for the axis of symmetry is x equals 0. What is the x-intercept, and what does the x-intercept represent in this situation? This time we only have one x-intercept, and it is right here. So that x-intercept is 4, 0. Remember, there's always a 0 in the y place. What does that x-intercept represent? The time it takes the acorn to hit the ground. It takes the acorn 4 seconds to hit the ground after it falls from that tree. So after 4 seconds, it hits the ground. What does the y-intercept, or what is the y-intercept and what does it represent? The y-intercept is up here. Right? It's also my maximum. What it represents is the starting height of the acorn, or the starting point. that was, my ordered pair is 0, 20. So it is 20 feet. They tell us it starts 20 feet above the ground. So what is the reasonable domain for this situation? And are there any values that would be unreasonable to include? So we're going to do the same thing, smallest x, biggest x. For range, we're going to do smallest y, biggest y. So I'm going to have my inequality, go up to my table. My smallest x value is 0. My biggest x value is 4, because it only takes 4 seconds. So it goes from 0 seconds to 4 seconds. And it can equal both of those numbers because at 0 seconds it's in the tree, and when it equals 4 seconds it's on the ground. Unreasonable, I'm not going to write, but it's the same thing. Any negative numbers, and this time it is anything greater than 4. I said I wasn't going to write it, and I'm writing it. Negative numbers and anything greater than 4 is the unreasonable. For the range, we're looking at our y values. So my smallest y is way over here, is 0, and my biggest y is 20. So don't put 20 over here because it was first in the table. The smallest one goes on the left, the biggest one goes on the right. Does it equal or does it reach 0 feet? Yes, when it's on the ground. Does it equal or ever reach 20 feet? Yes, when it is on the tree. So this time it would be any negative numbers and anything greater than 20, because it's not going to float up. If it falls, it's going to go straight down. So it's not going to reach anything higher than 20. A recap from last time. List the other names for the X-intercepts. There were 3 other words. Those 3 words are zeros, roots, and solutions. What is the name of the min or max? I said that a couple of times already. The min or max is always the vertex, that middle point. All right, we're almost done. I know this has been a long one. Last one. So this time we're doing the same thing except we don't have a graph or we don't have a word problem. We're only using the function that they've given us. So we're going to do the same thing. I'm not going to do both of them, just to try to save us a little bit of time, or we'll see how fast I can get through this next one. So, graph the function in your calculator. Well, we need to be able to graph it to be able to get the table to see all those numbers. So, add a graph. Remember, we only start typing in after the equal sign. So, I have x squared plus 2x plus 3. Okay, so I know my parabola is a positive parabola. It looks like this. And if you're not in my class, I tell my kids that they know it's positive because if we add little eyes, it looks like it's smiling. So if you're smiling, you're normally in a positive mood. So this is a positive parabola. I need to find the vertex. Okay, so I'm going to do it a little bit different this time. Not using the table. So I'm going to go to menu. We're going to go to Analyze Graph. And if I want to find the vertex, that means I'm looking for this point right here, because the vertex is in the middle, right? That is also my minimum. So I am going to go to Analyze Graph, and I am going to select minimum. This is like when we were finding the point of the solutions with the systems of equations, where we were looking where those 2 lines intersected. So I'm going to drag it to one side of where I know that minimum or vertex is. I'm going to click, I'm going to slide, and I'm going to click. And it tells me what my minimum is. It's kind of hard to see because of the other numbers, so I'm going to move it a little bit. So my minimum is -1, 2. Or sorry, my vertex. -1, 2. Now, once I have that number, I already have 2 things, and hopefully you remember this from last time. From my graph, I know that this is a minimum. So I'm going to circle minimum, and the minimum is only the y value. So this is my y value. So my y goes here, for my minimum value is 2. Now, the axis of symmetry always goes through the vertex, and the axis of symmetry is always x equals. Well, if I look at the x value of my vertex, it is -1. So that vertex gives me the value I need for my max or min, and it gives me the axis of symmetry. Now, if I look at this graph, zeros is the same thing as x-intercepts. And x-intercepts is where the graph or the parabola intersects the x-axis or touches it, and it doesn't. So this one has none. There are no zeros or x-intercepts. Now, the y-intercept is right there. To find, we're going to do analyze graph again. So menu, or sorry, not analyze graph, trace. So menu, trace, graph trace. Some of you have used this last semester. And when you do graph trace, most of the time it's going to take you directly to that y-intercept. So my y-intercept is 0, 3. Or you can do Control T, and you know that the y-intercept always has a 0 in the x place. So you look to where you have a 0 in the x place on your table if you want to do it that way. Now, here's where it changes a little bit from what we were doing with the word problems. The domain of any quadratic function that does not have a word problem, the domain is always all real numbers when you don't have a word problem. All real numbers. Now, there's a symbol that looks like a double-backed R. So I draw 2 lines, and then I just connect it with the R using that back line. This means all real numbers. When you have a quadratic, and we know we have a quadratic because it's x squared. When you have a quadratic and there's no word problem, the domain is always all real numbers. Now, the range is going to change depending on what your parabola looks like. So I know that this point is -1, 2. So my range is the y value. That's my y value. It doesn't go any lower than 2. It goes 2, and these arrows move up. So my y values are always going to be greater than or equal to 2. Greater than or equal to 2. Okay, let's do the last one. I don't want to give you just one example because this one was a little different, and we did some things that were a little different in the calculator. So last one, we're going to graph. I'm only going to type in -3x squared minus 6x plus 4. All right, this time my parabola is negative. All right, it looks like this. If I add eyes up here, it looks like it's frowning, so it's negative. I'm going to find the vertex. Well, my vertex is up here, and this time it is a maximum. So I'm going to go menu, analyze graph, but this time I'm going to select maximum. It moves it a little bit for me because we couldn't really see the very top of it, and it tells me that the vertex is -1, 7. I have a maximum this time. The max is going to be the y value, so my max is 7. The axis of symmetry also comes from the vertex, but this time I'm looking at the x value. So x equals -1. Zeros. I have 2. If I zoom in instead of zoom out, we can see that that parabola intersects the x-axis at 2 different places. The calculator will tell us what it is. Menu, analyze graph. I'm looking for the 0. There's 2 of them, so we have to do it separately. My line is closer to this one, so I'm going to find that one first. So I just highlight where I know that the graph intersects the x-axis, and it tells me that my first x-intercept is 0.528, 0, and I'm going to do the same thing over here on this side. Menu, analyze graph, 0, highlight that x-intercept, and my second 0 is negative 2.53, 0. My y-intercept, remember we did that with graph trace. Menu, trace, graph trace. And it takes me directly to that y-intercept. And I know it's the y-intercept because there is a 0 in the x place. So 0, 4. Domain. Do I have a word problem? No. Do I have a parabola? Yes. So the domain is always all real numbers because there is no word problem. This graph is going to continue to move down, and as it moves down, it's going to get wider and wider and wider. It's going to go all the way from the left, all the way to the right. Negative infinity to positive infinity is all real numbers. Now the range comes from that y value because the range is the y value. Well, my y value is 7, right? Negative 1, 7 up here. So this is 7. It doesn't go any higher than 7. So it's 7 and below. So my y value this time is less than or equal to 7 because it doesn't get any higher than 7. Don't forget to do your summary and work on your apply.